Hi, welcome to my YouTube channel Vaishnav360. Like, share, subscribe, and do not forget to hit the bell icon.
Hello guys, welcome to Vaishnav 360. Today we are going to do mathematical induction, the new chapter. Now we are going to do the introduction first, okay? In introduction, we should know only 3 steps which are most important to do a problem. Only 3 steps, okay? We'll write now here. 3 steps are, we should write first heading now, that is steps to prove. We should know the steps to prove. These are for the problems which we have to prove, okay? Now the first one is basis of introduction. Next one is show that P of 1 is true. Now the second one is inductive hypothesis. I will write everything by reading once, and now I will, and then I will explain. Okay, explain after writing whole thing. For k greater than 1, comma, assume that P of k is true, and the third one, that is inductive step. Show that P of k plus 1 is true on the, here I will write, on the basis of the inductive hypothesis. So here I will explain you now. Steps to prove. We have 3 steps which are the most important to prove the uh, problems. So the first one is basis of introduction. In this, we get to know that they show that P of 1 or P of any variable is true. Then the next step we do is inductive hypothesis, through which we know that k is greater than 1. If now we get in any example this variable is greater than 1 or any other term, then we should assume that P of k is true. Okay, in inductive step we should show that P of k plus 1 is true on the basis of inductive hypothesis, that is this one. For k is greater than 1, assume that P of k is true. On this we should make P of k plus 1 is true on the basis of this thing, this one. Okay, now we have completed the introduction. We'll get into the problems. Okay, now we are going to do exercise number 21. In this lesson there is only one exercise, that is exercise number 2a. I told it 21, sorry, it is 2a. Now we have the question, that is using mathematical induction prove each of the following statement for all n belongs to caps n. Caps n is nothing but natural numbers. Now I will read the question again. Using mathematical induction prove each of the following statement for all the variable n belongs to natural numbers. Okay, the first question here is n square plus 2 square plus 3 square plus till n square is equals to n of n plus 1 of 2n plus 1 by 6. Okay, now we will solve the problem. Okay, let us take p of n be the given statement and p of n is equals to 1 square plus 2 square plus 3 square plus till n square is equals to n of n plus 1 into 2n plus 1 by 6. Now p of n, sorry, p of 1 is equals to 1 square is equals to 1 of 1 plus 1 of 2 plus 1 by 6 is equals to 1, that is equals to 1 of 2 into 3 by 6, that implies 1 is equals to 1. This is so much long question and long answer, but we should know these three steps to prove, so that it will become easy and simpler for you, and you can easily do the problems and gain marks in the exam. Only these three steps we have to learn and apply it on the question. Okay, now these are very simple multiplication, so I am not explaining that deeply. Okay, because you would learn it in the ninth class only, I think eighth class only. Okay, now we will write, therefore p of 1 is true for n is equals to 1. Now we will assume that p of n is true for n is equals to k. Okay, now we will take p of n is equals to 1 square plus 2 square plus 3 square plus till x square plus x square is equals to k of k plus 1 2k plus 1 into 2k plus 1 by 6. This is the first equation we get. Now here I will write we have to show that that given statement is true for n is equals to k plus 1, then we will get p of k plus 1 is equals to k plus 1 of k plus 1 plus 1 of 2 of k plus 1 plus 1 by 6. Now here we will get k plus 1 of k plus 2 of 2k plus 3 by 6 is the second equation. Now we will go to the next step, that is we will consider p of k plus 1. Wait a second. Here we will consider k plus 1. P of k plus 1 is equals to 1 square plus 2 square plus 3 square plus till plus k square plus k plus 1 square. Here 1, here square. Okay, sorry for this um, uneven type of writing. Now k square. Okay, now I will get here, wait, now here, right? Now here I will get p of k plus 1 is equals to p of k plus k plus 1 square is equals to k of k plus 1 of 2k plus 1 by 6. Here we will get another addition. I will write it down. Okay, here um, here we will get k plus 1 square. I have written here. This whole set is equation number 2. Sorry, equation number 1. From we get this from equation number 1. Now I will write here k plus 1 of k plus 1 of k of 2k plus 1 by 6 plus k plus 1, here big bracket. Okay, then we will get k plus 1 of 2k square plus k plus 6k plus 6 by 6. Okay, now here I will get k plus 1 of 2k square plus 7k plus 6 by 6. Okay, now I will get here k plus 1 of k plus 2 of 2k plus 3 by 6. Here this is a quadratic equation, no? So we should divide this part. To divide this part, I have done here like this 2k square, and we have separate 3k, 4k. If we multiply 12k square, if we add 7k. Okay, now we will get here 2k square plus 4k plus 3k plus 6, and the next one will get 2. Wait, I will write we will get 2k plus k plus 2 plus 3 of k plus 2. Okay, now here I will get total answer k plus 2 of 2k plus 3. This is the answer for this quadratic equation. I have applied it here. Here I have applied it. Then I can write here, that is p of k plus 1. Therefore p of k plus 1 is true for n is equals to k plus 1. Therefore the given statement p of n is true for all and belongs to caps n. This is the answer for the first question. Okay, now we are going to do the second question, that is, now here we are with the second question, that is 2.3 plus 3.4 plus 4.5 plus until nth term, then it is equals to n of n square plus 6n plus 11 by 3. Now here we'll solve the question. The first statement, here nth term is n plus 1 of n plus 2. Okay, n plus 1 and 2. Let P of n be the given statement. Okay, we will now take P of n is equals to 2 into 3 plus 3 into 4 plus 4 into 5 up till plus n plus 1 of n plus 2 is equals to n of n square plus 6n plus 11 by 3. Okay, now here for n is equals to 1, 2 into 3 is equals to 1 of 1 plus 6 plus 11 by 3, that is equals to 18 by 3, and 3 6 are 18, no? Then 6 is equals to here 6. So we have proved that it is true. Now we'll write the statement, that is therefore P of 1 is true for n is equals to 1. Then we'll assume that P of k is true for n is equals to k. P of k here equals to 2 into 3 plus 3 into 4 plus 4 into 5 plus k plus 1 k plus 2. Okay, of k plus 2, sorry. Now we'll get here k of k square plus 6k plus 11 by 3. Okay, these are so simple multiplications, but the answer is too lengthy, so you may think it is hard, but it is so simple. We should just remind the three steps to prove and then write down the answer. Okay, now here we have to show that given statement is true for h is equals to k plus 1. Then now we'll get p of k plus 1. Oh, sorry, I was seeing h up and wrote h here. It is n. Okay, n here. Okay, n. P of k plus 1 is equals to k plus 1 of k plus 1 of k plus 1 square plus 6k plus 1 plus 11 by 3. Okay, now here we'll get k plus 1 of k square plus 1 plus 2k plus 6k plus 6 plus 11 by 3. Now here we'll get the second equation. Wait a second, sorry for this. Oh, right, now here we'll get p of k plus 1 is equals to k plus 1 of k square plus 1 plus 2k plus 6k plus 6 plus 11 by 3. Now we'll get k plus 1 of k square plus 8k plus 18 by 3. How did I get this? By adding this. Okay, if you add you will get this answer. Now we'll consider here, wait a second, let me go up so that again you may not uh, here, wait, now, right. Okay, now here we should consider here, no, consider p of k plus 1 is equals to 2 into 3 plus 3 into 4 plus 4 into 5 plus till k plus 1 of k plus 2 plus again k plus 2 till of k plus 3. Okay, now we'll get here p of k plus 1 equals to p of k is equals to 2 into 3 plus no, sorry, here k p of k plus k plus 2 of k plus 3. Okay, this is the above part, we should separate it. Okay, this is separate. Now this is the statement we will get. Now we will continue solving this. That is, here we will get uh, k of k square plus 6k plus 11 by 3 plus k plus 2 of k plus 3. Okay, now in the next step we will get k cube plus 6k square plus 11k plus k square. Okay, done. Now here by 3 here, and we will get plus 3k plus 2k plus 6. Okay, now in the next step I will get um, k cube plus 6k square plus 11k plus 3k square plus 15k plus 18 by 3. How did I get this? By taking LCM. Here I took LCM for this and I got this answer. Now I'll get here. This is very insufficient. Now I'll write here. We'll get here k cube plus 9k square plus 26k plus 18 by 3. Okay. Now here we are going to do the synthetic division. Okay. This is not the cloth type synthetic. This is a mathematical way of dividing a equation. Okay, k is equals to minus 1 because here k plus 1 is equals to 0. K is equals to minus 1 now. That's why. Now we'll get here 1 9 26 18. Now 0 minus 1 is 1. 1 1 minus 1 is minus 1. Then it is 8. 8 minus 1 is minus 8. Then it is 18. Now 18 minus 1 is minus 18. Now 0. Therefore p of k plus 1 is equals to 1 by 3 of k plus 1 of k square plus 8k plus 18. Therefore the given statement here given statement is true for n is equals to k plus 1. Okay, therefore p of n is equals to 2 into 3 plus 3 into 4 plus 4 into 5 plus n plus 1 of n plus 2. It is equals to now it is equals to n of n square plus 6n plus 11 by 3. So this is true for all n belongs to capital N. This is the answer for the second question. Now we are going to do the third question. That is, now we are going to do the third problem, that is 1 by 1.3 plus 1 by 3.5 plus 1 by 5.7 plus 1 by 5.7 up until 1 by 2n minus 1 of 2n plus 1 is equals to n by 2n plus 1. Okay, now we are going to solve the question. Here we will take for n is equals to 1, p of 1 is equals to 1 by 1 into 3. Here point I have read point, no, here point is multiplication. Okay, is equals to 1 by 2 of 1 plus 1 is equals to 1 by 3 is equals to again 1 by 3. Hence we can tell the given statement is true for p of 1, or we can write therefore p of 1 is true for n is equals to 1. Okay, now the next step here is let us assume that given statement is true for n is equals to k. For here for n is equals to k, then 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus until plus 1 by 2k minus 1 of 2k plus 1 is equals to k by 2k plus 1. This is the first equation here we get. Now the next equation we get here is we have to prove that given statement is true for n is equals to k plus 1. Now for p of k plus 1 is equals to k plus 1 by 2k 2 of k plus 1 plus 1. This is the second equation. Now we'll get consider p of k plus 1 is equals to 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 up to plus 1 by 2k minus 1 of 2k plus 1 plus 1 by 2 of k plus 1 minus 1 and again 2k plus 1 plus 1. Here minus, here plus. Okay, now here we'll get, oh sorry for this. Now I think you might see this is what I have written before. Let me go up. Yeah, till here you might see. Now I will get here p of k is plus, here is equals to p of k plus 1 by 2k plus 2 minus 1 2k plus 2 plus 1. Okay, now here we will get uh, that is k by 2k plus 1 plus 1 by 2k plus 2 minus 1 of 2k plus 2. Okay, here 2 plus 1 is 3, no? Here 3 it will come, okay? Here 2 minus 1, here 1 plus 1, okay? I'm writing double time, sorry. Now here I will get 1 by 2k plus 1 of k plus 1 by 2k plus 3, okay? Now here total I will get 1 by 2k plus 1 of 2k square plus 3k plus 1 by 2k plus 3. Oh, here you might see now this I have written now, okay? Now we'll go to the next step, that is, now here the next step is 1 by 2k plus 1 of k plus 1 of 2k plus 1 by 2k plus 3. Now this and this get cancels, okay? Now here we will get k plus 1 by 2k plus 3, that is equals to k plus 1 by 2k plus 2 plus 1. We can write it as like this. Now here k plus 1 by 2 of k plus 1 of plus 1, okay? You might think, how did I get k here, k plus 1 and 2k plus 1? Here I will write 2k square, here I will divide 2k and here 1k. 2k of k plus 1 plus k plus 1, that is here, okay? Done. Here k, okay? Now I'll get k plus 1 of here 1 only, no, right? 1. Here I will get 2k plus 1 here. This is how I got this quadratic equation in simpler form. Now this is the answer. Therefore, given statement is true for n is equals to k plus 1, and therefore the given statement is sorry, I will write here, p of n is true for all n belongs to natural numbers. So this is the answer for the third question. Now we'll go forward to the fourth question, that is, now we are going to do the fourth bit, that is 4 cube plus 8 cube plus 12 cube plus until n or up to n terms, that is equals to 16 square of n plus 1 whole square. Okay, let's start the problem. Okay, let p of n be the given statement. Okay, 4 cube plus 8 cube plus 12 cube plus until 4n whole cube is equals to 16n square of n plus 1 whole square. Okay, now here we will write, what can we write here? We can write for n is equals to 1 comma p of 1 is equals to 4 cube is equals to 16 of 1 square of 1 plus 1 whole square. Okay, 64 is equals to 16 of 2 to the power 2. 16 64 is equals to 16 into 2 to the 4. So 16 into 4, that is 64. So 64 is equals to 64. Therefore, P of 1 is true for n is equals to 1. Okay. Wait, let me raise it up. Yeah, from here. Okay, let us take, or let us assume that given statement is true for n is equals to k plus 1. P of k plus 1 is equals to 16 of k plus 1 whole square of k plus 1 plus 1 whole square. Okay, now here I will get 16 of k square plus 1 plus 2k of k square plus 1 plus 2k plus 1 plus 2k plus 2. I can write this in form of this, no, using formula. So I have written it. Now I will get 16k square plus 2k, 16 of k square plus 2k plus 1 of k square plus 4k plus 4. Okay, now let's consider, let me raise it up. So let us consider P of k plus 1 is equals to 4 cube plus 8 cube plus 12 cube plus until 4k whole cube plus 4 of k plus 1 whole cube. Okay, now it is equals to P of k plus 4 of k plus 1 whole cube, since from equation 1. Okay, now we can write down that 16k square of k plus 1 whole square plus 64 of k plus 1 whole cube. Next we can write 16 of k plus 1 whole square of k square plus 4k plus 4. Now here we can distribute this 4k and 4 by 16 of k plus 1 whole square of k square plus 2k plus 1 plus 2k plus 2 plus 1. Okay, now I will get here 16 of k plus 1 whole square of k plus 1 plus 1 whole square. Okay, now there is therefore statement, and this is the answer. We are going to write therefore statement now. Okay, the therefore statement here is, therefore the given statement is true. Okay, wait a second. Yeah, here we can write true for n is equals to x plus 1, and again there is another statement through that we can conclude the whole answer, that is therefore the given statement p of n is true for n belongs to natural numbers. Therefore we have completed the fourth question. Let's go forward to the fifth question, that is a plus a a plus a plus d and plus a plus 2d plus until nth term, that is equals to n by 2 of 2a plus n minus 1 of d. Now we are going to solve this question. Okay, now the first term here is, let p is the term of n is given statement. Okay, now p of n is equals to a plus d plus a plus 2d plus up to a of n minus 1 of d is equals to n by 2 of 2a plus n minus 1 of d. Okay, for n is equals to 1, comma p of 1 is equals to a is equals to 1 by 2 of 2a plus 1 minus 1 of d. Okay, now here I will get 1 by 2 of 2a plus 0 of d equals to 1 by 2a. Okay, because 0 into d is 0 and 2a plus 0 is 2a only, no? And here in multiplication we'll divide 1 by 2 and 2a. 2 gets cancelled and it will become a. Okay, here a equals to a, therefore p of 1 is true for n is equals to 1. Okay, here let us assume that p of n is true for n is equals to k. P of k is equals to a plus d plus a plus 2d plus up to a of k minus 1 of d, that is equals to k by 2 of 2a plus k minus 1 of d, that is the equation number 1. Okay, we have to prove that the given statement is true for n. Here, right? Yeah, true for n equals to k plus 1. Okay, this is the statement which is true for n is equals to k plus 1. Now we will write the next step, that is p of k. Let me write here. Wait a second. Let me raise it a bit so that you can see it. Again, it will not be a problem. Now, okay. Now the next step is p of k plus 1 is equals to k plus 1 by 2 of 2a plus k plus 1 minus 1 of d is equals to k plus 1 of 2 of 2a plus k of d is the second equation. Now let's consider p of k plus 1 is equals to a plus d plus a plus 2d plus until plus a plus k minus 1 of d plus a plus k plus 1 minus 1 of d. Okay, now wait a second, let me raise it. Yeah, now here I will get p of k plus a plus k of d. Okay, then k by 2 of 2a plus k minus 1 of d plus a plus kd. Okay, that is now equals to 2ak plus kd of k minus 1 by 2. Okay, by 2 plus a plus kd. Okay, the next step is, now the next step is here we can write 2a of k plus 1 plus kd of k minus 1 plus 2 by 2. Okay, that is equals to 2a of k plus 1 plus kd of k plus 1. Okay, by 2. Okay, now here the next step we'll get is k plus 1 of 2a plus kd by 2, which is equals to k plus 1 by 2 into 2a plus kd. Okay, this is the answer. Now we'll write the therefore statement. Therefore given statement is true for n is equals to k plus 1, and therefore the given statement p of n is true for all n belongs to natural numbers. This is the end for the fifth question. Now we are going to do the sixth question, that is, here we are with the sixth question, that is a plus ar square plus until n term, that is equals to a of r to the power of n minus 1 by r minus 1, comma r is not equal to 1. Now we will solve this problem. Okay, the first step is let p of n be given statement, then p of n is equals to a plus ar plus ar square plus up to plus ar to the power of n minus 1 equals to a of r to the power of n minus 1 by r minus 1. This one is the first equation. Now for n is equals to 1, p of 1 is equals to a is equals to a of r to the power of 1 minus 1 by r minus 1. Here minus 1, r minus 1 and r minus 1 get cancelled, and a is equals to a. Therefore p of 1 is true for n is equals to 1. We have to assume ASSUM, assume that given statement is true, okay, is true for n is equals to k, then we'll get here. Wait a second, let me raise it up. Okay, now we'll get here p of k plus 1 is equals to a of r to the power k plus 1 minus 1 by r minus 1. This is the uh, wait a second, I did a little mistake. Oh, sorry, I wrote k here and k plus 1 here. I should write this one is last one, no? I should write here. Wait. Sorry for this mistake. This one step is a mistake, okay? Let me take here. Yeah. Here p of k, no, is equals to ar plus ar square plus until ar to the power k minus 1 is equals to a of r to the power k minus 1 by r minus 1. This is the second equation which we get. Now we have to prove that given statement is true for n is equals to k plus 1. Now here we will get p of k plus 1, okay, which is a of r to the power k plus 1 k plus 1 minus 1 by r minus 1. This is the third equation which we get, okay. The next step here is, let us consider p of k plus 1 is equals to a plus ar plus ar square plus until ar to the power k minus 1 plus ar to the power k plus 1 minus 1. Here plus 1 minus 1 get cancels, okay. Now here p of k will get here p of k plus ar to the power k, which is from equation 2 and from equation 1, okay. Now the next step here is a of r to the power k minus 1 by r minus 1 plus ar to the power k, which implies a of r to the power k minus 1 by r minus 1 plus r to the power k, okay. Now a of r to the power k minus 1 plus r to the power k of r minus 1 by r minus 1. Now we'll get here a of r to the power k minus 1 plus r to the power k plus 1 minus r to the power k. Here opening the brackets here. These were the brackets which we have before. Now we have opened and we got this, and then we will get here r minus 1, which implies a of r to the power k plus 1 minus 1 by r minus 1, okay. We will think, how did it get a to the r to the power k plus 1? Here there is a formula, a to the power of m into a to the power of n is equal to a to the power of m plus n. This is the formula through which I have done. Okay, hence it is true for n is equals to k plus 1. Therefore, the given statement p of n is true for all n belongs to natural numbers. So we have completed the sixth problem. Now we'll head towards the seventh problem, that is, now here we are with the seventh problem, that is 2 plus 7 plus 12 plus up to 5n minus 3 is equals to n of 5n minus 1 by 2. Okay, now let's solve this problem. Let p of n be the given statement. Okay, now p of n is equals to 2 plus 7 plus 12 plus up to 5n minus 3 is equals to n of 5n minus 1 by 2. This is the first equation which we get now here. Okay, now here for n is equals to 1 is equals to p of 1 is equals to 1 by f of 1 minus 1, sorry, 5 of 1 minus 1, 5 of 1 is 5 only, no, 1 of 4 by 2, 2 2s are 4, 2 is equals to 2. Okay, therefore p of 1 is true for n is equals to 1. Okay, now we have to assume that given statement is true. Okay, for n is equals to k, p of k is equals to 2 plus 7 plus 12 plus plus 5 of we will write here uh, 5k minus 3 is equals to k of 5k minus 1 by 2. This is the second equation now which we have got. Now we'll write, we have to prove that given statement is true for n is equals to k plus 1. P of k here plus 1 is equals to k plus 1 of 5k 5 of k plus 1 minus 1 by 2, which implies k plus 1 of 5k plus 5 minus 1 by 2. That implies x plus 1 of 5k plus 4 by 2. Now we will consider p of k plus 1 is equals to 2 plus 7 plus 12 plus up to plus 5k minus 3 plus 5 of k plus 1 minus 3. Okay, now p of k, which here from here, this is continuation of this. So p of k plus 5k plus 5 minus 3 is equals to k of 5k minus 1 by 2 plus 5k plus 2. Okay, now 5k square minus k plus 10k plus 4 by 2 is equals to, now it implies 5k square plus 9k plus 4 by 2. Now here we can write this as k plus 1 of 5k plus 5 minus 1 by 2, which implies now k plus 1 of 5k plus 1, okay, minus 1 by 2. Now we can write the final answer, that is, now we can write here, therefore it is true for n is equals to k. Now we have completed the seventh problem. Now we will go to the next one. Here I have written a mistake. It is true for n is equals to k plus 1, and therefore given statement p of n is true for n belongs to natural numbers. This is the two therefore statements which we have to write after the question in the answer. Okay, we have completed the 7th question till here. This is the end of the 7th question. Now we are in the 8th question, that is 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9 up to 1 plus 2n plus 1 by 2n plus 1 by n square is equals to n plus 1 whole square. So we'll solve this problem now. Now here we are with the 8th question, that is I have talked about it already. Now we'll solve the question. The first step here is p of n is equals to 1 plus 3 by 1, okay, 1 plus 5 by 4, and 1 plus 1 plus 7 by 9, okay, up to 1 plus 2n plus 1 by n square, okay, is equals to n plus 1 whole square. Then here for n is equals to 1, then p of 1 is equals to 1 plus 3 is equals to 1 plus 1 whole square. Now it implies 4 is equals to 2 square, 4 is equals to 4. Now therefore p of 1 is true for n is equals to 1. Let us assume that given statement is true for n is equals to k. Okay, now here P of k is equals to 1 plus 3 by 1, that is 1 plus 5 by 4 of 1, sorry, I told here that is, but it is multiplication. Now here also multiplication, then 1 plus 7 by 9, then the up to multiplied by 1 plus 2k plus 1 by k square. Okay, that is equals to k plus 1 whole square. We have to show that given statement is true for n is equals to k plus 1. Okay, now here we have got the first equation. Okay, now we'll write here p of k plus 1 is equals to k plus 1 whole square is equals to k plus 2 whole square is equals to k square plus 4 plus 4k. Okay, now we will consider p of, here we will consider p of k plus 1 is equals to 1 plus 3 by 1 and 1 plus 5 by 4, 1 plus 7 by 9 up to 1 plus 2k plus 1 by k square and into 1 plus 2 of k plus 1 by k plus 1 whole square plus 1. Okay, now here, wait a second, I will raise it up and continue. Yeah, so now here we have considered, no? Okay, now here p of k plus 1 whole square plus 2k plus 2 plus 1 by k plus 1 whole square. This is from equation 1. Okay, we have got this from equation 1. Now k plus 1 whole square of k square plus 1 plus 2k plus 2k plus 3. I have divided this, okay, and did k plus 1 whole square formula. I have used the formula and completed it. Now here k plus 1 whole square. Okay, here k plus 1 whole square, here k plus 1 whole square gets cancelled and we'll get k square plus 4k plus 4, that is k plus 2 whole square, that is k plus 1 plus 1 whole square. What is this k plus 1? Okay, k plus 1 plus 1 whole square. This is nothing but we got this in the above, that is, comment me if we have got this answer anywhere above. I will show you it again. Okay, if we have got, comment in the comment section. Okay, now we'll write therefore statement. The given statement is true for n is equals to k plus 1, and therefore p of n is true for n belongs to capital N, that is natural numbers. Okay, now we have completed the 8th question. We will go to the 9th question, that is, now we are going to do the 9th problem, that is 2n plus 7 is smaller than n plus 3 whole square. Okay, now let us solve. Let p of n is equals to 2n plus 7, which is smaller than n plus 3 whole square, for n is equals to 1. P of 1 is equals to 2 of 1 plus 7, which is smaller than 1 plus 3 whole square. No? Now we will get 9, which is smaller than 4 square, and 9 is smaller than 16. So therefore P of 1 is true for n is equals to 1. Now let's assume that here this is S. Okay, SSUM. Assume that it is true for n is equals to k. Now here P of k is equals to 2k plus 7, which is smaller than k plus 3 whole square. This is the first equation which we get. Now we have to prove that the given statement is true for n is equals to k plus 1. Okay, now P of k plus 1 is equals to k plus 1 plus 3 whole square is equals to k plus 4 whole square, which is k square plus 16. 4 4 is 16 plus 8k, which is k square. Now I will repeat it, which is k square plus 16 plus 8k. Okay, now we will consider P of k plus 1, okay, is equals to 2k plus 1 plus 7, which equals to 2k plus 2 plus 7, which equals to 2k plus 7 plus 2, which is smaller than k plus 3 whole square plus 2. Okay, this we get from, wait a second, yeah, we got this from equation 1. Okay, now I will continue. 2k plus 7 plus 2 is smaller than k square plus 3 square plus 6k plus 2. Now I will not write this. This should be in every step. I will directly write, which is smaller than k square plus 9 plus 6k plus 2, and which implies which is smaller than k square plus 6k plus 11. which implies that it is smaller than k square plus 6k plus 2k minus 2k plus 11 plus 5 minus 5. We can write like this, no? Now it is smaller than k square plus 8k plus 16 of minus 2k minus 5. Now k plus 4 whole square minus 2k minus 5. Here we have written minus, no, so here plus, okay, plus 5. Now therefore we can write it as 2k plus 1, 2, 2 of k plus 1 plus 7 is smaller than k plus 4 square minus, okay, now you can see 4 square minus 2k plus 5, okay. Now here I will write, see, from here I will write, I think you may all see, yeah, now you may all see this, okay. Now 2 of k plus 1 plus 7, which is smaller than 1, 9, 9, what I am writing? Nonsense. Wait, this is k plus 4 whole square, okay. Now, which implies 2 of k plus 1 plus 7, which is smaller than k plus 1 plus 3 whole square, okay. Now, this is the answer. Therefore, the given statement is true for n is equals to k plus 1, and therefore p of n statement is true for all n belongs to capital N, that is natural numbers. This is the end of the 9th question. Now we will go to the next question, that is, now we are with the 10th question, that is 1 square plus 2 square plus up to n square, which is greater than n cube by 3. Now let us solve this question, okay. Let p of n be the given statement, okay. Then p of n is equals to 1 square plus 2 square plus up to n square is equals to n square plus 3 for n is equals to 1, which implies p of 1 is equals to 1 square, which is greater than 1 square by 3 is equals to 1 greater than 1 by 3, okay. Now therefore p of 1 is true for n is equals to 1. Now let us assume that given statement is true for n is equals to k, then p of k is equals to 1 square plus 2 square plus up to k square, that equals to k cube by 3, okay. This is the first equation which we get. Now we have to prove that given statement is true for n is equals to k plus 1. So here p of k plus 1 is equals to n square plus 2 square plus up to k square plus k plus 1 whole square, which is greater than k cube plus 3 plus k plus 1 whole square. This is from equation 1. Equation 1 this is okay. Now here I will write from here. Okay, I will not write the statement again. I will directly write greater than k cube by 3 plus k square plus 1 plus 2k greater than k cube plus 3k square plus 6k plus 3 by 3. Here k cube, here k 3k square, here 6k plus 3 by 3. Okay, which is now k cube plus 3k square plus 3k plus 3k plus 1 plus 2. We can divide this now like this by 3, which is equals to, which is greater than, here I will write, which is greater than which is greater than k cube plus 3k plus 3k plus 1 by 3 plus 3k plus 2 by 3, which is greater than k plus 1 whole cube by 3 plus 3k plus 2 by 3. Therefore 1 square plus 2 square plus k square plus k plus 1 whole cube by 3, which is greater than k plus 1 whole cube by 3. Okay, therefore we can write here p of n is true for n is equals to k plus 1, and therefore p of n statement is true for all n belongs to natural numbers. Okay, now we have completed the 10th question. Now we will go to the 11th question, that is 4 to the power n minus 3. Okay, minus 3n minus 1 is divisible by 9. So we are going to solve this question. Okay, firstly let p of n be the given statement that is p of n is equals to 4 to the power of n minus 3n minus 1 is divisible by 9 for n is equals to 1, that is equals to p of 1 is equals to 4 to the power 1 minus 3 of 1 minus 1, that equals to 4 minus 4, which is equals to 0, which is divisible by 9. This can be divisible by 9. Okay, now Therefore P of 1 is true for n is equals to 1. We should assume now that given statement is true for n is equals to k. P of k is equals to 4k minus 3k minus 1 is divisible by 9. 4 to the power k minus 3k minus 1 is equals to 90, where t belongs to n. This is the first equation. Now we have to prove that it is true for n is equals to k plus 1. P of k plus 1 is equals to 4k, 4 to the power k plus 1, okay, minus 3 of k plus 1 of minus 1, that is equals to 4 to the power k into 4 to the power 1 minus 3 k minus 3 minus 1, which is equals to 9t plus 3k plus 1 of 4 minus 3k minus 4. This is from equation 1, that is 4 to the power k is equals to 90 plus 3k plus 1. Okay, now here I think you may all see this. Okay, now 36t plus 12k plus 4 minus 3k minus 4 is equals to 36t plus 9k, because minus 4 plus 4 cancels and 12k minus 3k is 9k. Okay, therefore P of k plus 1 is divisible by 9, and here we also have therefore it is true for n is equals to k plus 1, and therefore the given statement P of n is true for all n belongs to caps n, that is natural numbers. Now we have completed the 11th question. Let's go forward to the 12th question, that is 3.5 to the power 2n plus 1 plus 2 to the power 3 and plus 1 is divisible by 17. Okay, now we will solve the problem, that is let P of n be the given statement, then P of n is equals to here 3.5 to the power 2n plus 1 plus 2 to the power 3n plus 1 is divisible by 17. For n is equals to 1, P of 1 is equals to 3 into 5 to the power 2 plus 1 plus 2 to the power 3 plus 1, which is equals to 3 into 5 to the power 3 plus 2 to the power 4 which is equals to 3 into 125 plus 16, okay, which is equals to 391, I think. Yeah, 391. So we can write it as 17 into 20, 23. So it is divisible by 17 by 23. So therefore P of 1 is true for n is equals to 1. Assume that it is true for n is equals to k. P of k is equals to 3.5 to the power 2 k plus 1 plus 2 to the power 3 k plus 1 is divisible by 17 equals to 3.5 to the power 2k plus 1 plus 2 to the power 3k plus 1, which is equals to 17t, where t belongs to natural numbers. This is first equation. Okay, now consider p of k plus 1 equals to 3.5 to the power 2 of k plus 1 plus 1 plus 2 to the power 3 of k plus 1 plus 1, okay, which is equals to now 3.5 to the power 2k plus 2 plus 1 plus 2 to the power 3k plus 3 plus 1. Okay, now here 3.5 to the power 2 point k plus 1 point 5 to the power 2 plus 2 to the power 3 k plus 4. Now this is from equation 1, okay, which is equals to 17t minus 2 to the power 3k plus 1 into 25 plus 2 to the power 3k plus 4. Okay, this is very simple, so I am telling it fastly. Now here it is 1, not 4. 1.2 to the power 3. Okay, here now 17t minus 2 to the power 3k plus 1 of 25 plus 2 to the power 3k plus 1 of 8. Okay, now here we can write 25 of 17t minus 25 of 2 to the power 3k plus 1 plus 8 of 2 to the power 3k plus 1, which is equals to 25 of 17t plus 2 to the power 3k plus 1 of 7 minus 17 of minus 17, which is equal to 17 of 25t minus 2 to the power 3k plus 1. Therefore p of k plus 1 is divisible by 17, and therefore p of n is true for all n belongs to natural numbers. Now we have completed the 12th question. Let's go forward to the 13th question, that is 1.2.3 plus 2.3.4 plus 3.4.5 plus till nth term, that is equals to n into or n of n plus 1 of n plus 2 of n plus 3 by 4. Now we are going to solve this question. First, let us take p of n be the given statement, then p of n is equals to 1 into 2 into 3. Here dots means multiplication, plus 2 into 3 into 4, 4 plus 3 into 4 into 5 till infinity, sorry, till nth term, that is n of n plus 1 of n plus 2, which is equals to n of n plus 1, n plus 2, n plus 3 by 4. Okay, now let n is equals to 1 comma p to the power, sorry, p of 1 is equals to, let n is equals to 1. Now here in place of n I wrote here 1. Then p of 1 is equals to 1 into 2 into 3 is equals to 1 of 1 plus 1, 1 plus 2, 1 plus 3. Here let n is equals to 1 and p of 1 is equals to 1 into 2 into 3, which is equals to 1 of 1 plus 1 of 1 plus 2 of 1 plus 3 by 4. Okay, therefore p of 1 is true for n is equals to 1. Okay, how did I did this? By here 2 into 3 6, here 4, and here 3 plus 1 4 cancels, 2 plus 1 3, 2 1 plus 1 2, 3 into 2 6, 6 is equal to 6, so it is true for n is equals to 1. Okay, now assume that it is true for n is equals to 4. Sorry, n is equals to k. I was writing here denominator, in that confusion I told you 4. It is k. P of k is equals to 1 into 2 into 3 plus 2 into 3 into 4 plus k of until k of k plus 1 of k plus 2, which is equals to k of k plus 1 of k plus 2 of k plus 3 by 4, which is the first equation. Okay, we have to prove the given statement is true for h equals to k plus 1. P of k plus 1 is equals to k plus 1 of k plus 1 plus 1 of k plus 1 plus 2 of k plus 1 plus 3 total by 4, which is equals to k plus 1 of k plus 2, k plus 1 of k plus 2 of k plus 3 of k plus 4, which is equals to 4, sorry, which is divided by 4. Let's consider Let us consider P of k plus 1, which is equals to 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus until k of k plus 1 of k plus 2 plus k plus 1 of k plus 1 plus 1 of k plus 1 plus 2. I think you may all see the place was insufficient, so I wrote down. Okay, from here I will explain now. Now we will write that is P of k plus k plus 1 of k plus 2 of k plus 3. We get this from equation 1. Okay, here equals to k of k plus 1 of k plus 2 of k plus 3 by 4 plus k plus 1 of k plus 2 of k plus 3, which is equals to k plus 1 of k plus 2 of k plus 3 of k plus 4 by 4. Now this is equals to k plus 1 of k plus 2 of k plus 3 of k plus 4 by 4. Now here we'll get total, that is k plus 1 of k plus 1 plus 1 of k plus 1 of plus 2 of k plus 1 plus 3 by 4. Therefore, the given statement is true for n is equals to k plus 1, and therefore p of n is true for all n belongs to natural numbers. Okay, this is the solution for the 13th question. Now we'll go ahead to the 14th question, that is going to do the 14th problem, that is 1 cube plus 1 cube plus 1 cube plus 2 cube plus 1 by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus up to nth term, that is equals to n by 24 of 2n square plus 9n plus 13. Now we are going to solve this problem. Here first, nth term equals to 1 cube plus 2 cube plus 3 cube plus up to plus n cube by 1 plus 3 plus uh, 1 plus 3 plus 5 plus up to 2n minus 1. Okay, which is equals to n square of n plus 1 whole square by 4 by n square, which is equals to n plus 1 whole square by 4. Here we can use the formula, that is summation of n, that is summation of the last term n by the formula is n by 2 of a plus l. Here n by 2 of 1 plus 2 n minus 1. Minus 1 plus 1 gets cancelled. Here n by 2, 2n remains. 2 gets cancelled. Now it will become n square. Okay. Now this is a rough part. Okay, we should not include here. This is the rough part. Now we'll get here uh, n square will get. Now here we will write, let p of n be the given statement. Okay, p of n is equals to 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus up to plus of n plus not plus n plus 1 whole square, not of n plus 1 whole square by 4, which is equals to n by 24 of 2n square plus 9n plus 13. Okay, now let us write for n is equals to 1, which is equals to 1 cube by 1 is equals to 1 by 24 of 2 plus 9 plus 13, which is equals to 1 is equals to 24 by 24, which is equals to 1 equals to 1. Therefore, we can write here p of 1 is true for n equals to 1. Now let's assume that it is true for n equals to k. Then p of k equals to 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus up to, here I will continue, plus k plus 1 whole square by 4 equals to k by 24 of 2k square plus 9k plus 13, which is the first equation. Now we have to prove that it is true for n equals to k. Now p of k plus 1 is equals to k plus 1 by 24 of 2 of k plus 1 whole square plus 9 of k plus 1 plus 13, which is equals to k plus 1 by 24 of 2 of k plus 1 plus 2 k square plus 1 plus 2k. I have separated it, means by using formula I have splitted it. Now plus 9k plus 9 plus 13. These are very simple, what do we say, calculations. So I am not telling it deeply and making you understand, as you as all knows these small type of calculations. Okay, now here we will get k plus 1 by 24 of 2k square plus 2 plus 4k plus 9k plus 22, that is p of k plus 1, which is equals to k plus 1 by 24, then of 2k square plus 13k plus 24. Okay, now the next step here we will do is considering. The next step here we should do is considering. So consider p of k plus 1 equals to 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus up to plus, now we will write here, k plus 1 whole square by 4 plus k plus 1 plus 1 whole square by 4. Oh, sorry for this. Now I think you may also, yeah, you can see all this now clearly. Yeah, right. Now here we have got p of k plus 1 is equals to 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5, then plus up to k plus 1 whole square by 4 plus k plus 1 whole square by 4. Now in the next equation, which implies this continuation, which implies p of k plus k of plus, sorry, k plus 2 whole square by 4, this we will get from equation 1. Okay, from equation 1. Okay, now here we will get k by 24 of 2k square plus 9k plus 13 plus k square plus 2 square plus 4k plus 4k. Okay, now by 4 is equals to k plus, sorry, k by 24 of 2k square plus 9k plus 13 plus k square plus 4 plus 4k by 4. I think you may all understand. Few members cannot understand, can rewind the video again so that you can understand. If you cannot understand, please turn on your captions so that you can read and understand it. Okay, so here k of 2k square plus 9k plus 13 plus 6k square plus 24 plus 24k by 24. Till here we did not took the LCM. Now here we have separated it and we have multiplied this like this, and we have took whole divided by 24. Okay, now here we will get, wait, let me take it. Yeah, now here we will get 2k cube plus 9k square plus 13k plus 6k square plus 24 plus 24k by 24, which is equals to 2k cube 2k cube plus 15k square plus 37k plus 24 by 24. Now we will do synthetic division. We will take these numbers 2, 15, 37, 24, and we will divide it by k plus 1. We should know what is k here, no? Here we have in the above p of k plus 1, no? Here k plus 1 is equals to 0. Now k is equals to minus 1. This k equals to minus 1, okay? Now we will do here synthetic division. Wait a minute, let me take it up. Now here we will do synthetic division. Here we will take 2, 15, 37, 24. Here k is equals to minus 1, and we cannot take directly minus 1. We cannot take 2, no? So here minus 1 zeros are 0. So we'll get 2. Here 2, then minus 2. Here we got 2, no? Here we should write minus 2. What is 15 minus 2? That is 13. Now here minus 13. Minus 13 plus 37, which is, here it is 4, here it is 2, 24. Now minus 24, it is 0. Now we can write here, wait a second, yeah. Now we can write here, which is equals to k plus 1 of 2k square plus 13k plus 24 by 24, which is equals to k plus 1 by 24 of 2k square plus 2 plus 4k plus 9k plus 22. Okay, now we can write this as k plus 1 by 24 of 2 of k square plus 1 plus 2k plus 9k plus 9 plus 13. We can write this as again k plus 1 by 24 of 2k plus 1 whole square plus 9 of k plus 1 plus 13. This is the answer what we get. Now we'll write therefore statement. I think you may all see. Now we'll write therefore statement. That is, therefore it is true for n is equals to k plus 1, and therefore the given statement is true for all n belongs to capital N, that is natural numbers. Now we are going to do the last one, that is 15th question. That is, now we are with the 15th question, that is 1 square plus 1 square plus 2 plus 1 square plus 2 square plus 3 square plus up to n terms, which is equals to n of n plus 1 whole square of n plus 2 by 12. Okay, here n is equal n, here n term is equals to 1 square plus 2 square plus 3 square plus up to n square, which is equals to n of n plus 1 of 2n plus 1 by 6, which is p of n uh, equals to, wait a second, I forgot to write one statement. Yeah, here let p of n be the statement, then we'll write p of n is equals to 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus up to n of n plus 1 of 2 plus 2n plus 1 by 6, which is equals to n of n plus 1 whole square of n plus 2 by 12. Okay, now here we will write for n is equals to 1, which is equals to 1 square equals to, yeah, now you may all see this. Now 1 of 1 plus 1 of whole square of 1 plus 2 by 12, which is equals to 1 is equals to 4 into 3 by 12. What is 4 into 3? 12. Here 12. 12 and 12 get cancelled. Now equals to 1 equals to 1. Okay. Therefore here P of 1 is true for n equals to 1. Okay. So we'll write here assume that it is true for n is equals to k. P of k equals to 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus up to plus k of k plus 1 of 2k plus 1 by 6. We have to prove that it is true for n is equals to k plus 1. Now P of k plus 1 equals to k plus 1 of k plus 1 plus 1 whole square of k plus 1 plus 2. Then we'll get 12 by 12, which is equals to, then we'll get here k plus 1 of k plus 2 whole square of k plus 3 by 12. Let's consider here P of k plus 1, which is equals to 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus up to plus k of k plus 1 of 2k plus 1 by whole by 6. Okay, now we will get, wait a second, here we will also get plus k plus 1 of k plus 1 plus 1 of 2k plus 1 of plus 1. Here I think you may all see this. It is a little congested way, but I have told you, no, so you note it down as I tell you. Plus 1, no, here by, it is not whole divided by, from here to here only, by 6. Now we can write it as k plus 1 of k plus 2 of 2k plus 2k plus 2 plus 1 by 6. Here we will get P of k, P of k plus, okay, this is separate and this is separate, so I have written separately now here. Okay, now this will get from equation 1, we'll get it from equation 1, we'll get this equation, this one. Okay, Now let us continue. K of k plus 1 whole square of k plus 2 by 12 plus k plus 1 of k plus 2 of 2k plus 3 by 6, which is here equals to k plus 1 of k plus 2 of k plus 1 plus 4k plus 6 by 12. K plus 1 of k plus 2 of k square plus k plus 4k plus 6 by 12. Oh, sorry. Yeah, now you can see this. Okay, now here we'll get k plus 1 of k plus 2 of k square plus 5k plus 6 whole divided by 12 is equals to k plus 1 of k plus 2 by 12 of k square plus 5k plus 6. You might think, how did I divide this? Now I'll show you how will I divide this. 6k square, I will divide it by 6k 1k, no, 2k and 3k here. Okay, like this I will divide. I will show you how to write it now. Okay, so now here I can write it as k plus 1. I am writing whole statement. K plus 1 of k plus 2 by 12 of k plus 2 of k plus 2, sorry, k plus 3. Okay, now here we will get k plus 1. Okay, here we will get k plus 1 of k plus 2 whole square of k plus 3 by 12, which is now equals to k plus 1 of k plus 1 plus 1 whole square. Here we will get k plus 1 plus 1 whole square of k plus 3. Okay, by 12. Now we can write here, therefore it is true for n equals to k plus 1, and therefore the given statement p of n is true for all n belongs to natural numbers. Now we have completed the 15th question. Now here we have completed the lesson mathematical induction.